Good morning, this is Dr. Kumar Arya, Associate Professor in Department of Chemical Engineering, IIT Jalandhar. Today I am going to explain non-dimensionalizations of equation of motion. So it requires to properly compare the order of magnitudes of various terms in the equations. It always helps which term will need to be considered for better simplifications. The Weierstrass equation for incompressible flow of Newtonian fluid with constant property is given by this: rho del dB upon dt equal to rho del V upon del T plus V dot del bracket close into B equal to minus del P plus rho G plus mu del square V actually. So scaling factors we are considering here, that first is length, characteristic length dimension is L. Second is velocity, characteristic speed Lt minus 1. Then F, characteristic frequency T minus 1. P naught minus P infinity reference pressure difference ML minus 1 T minus 2. Gravitational acceleration G Lt minus 2. Then non-dimensional time is given by Ft, non-dimensional length is given by x upon L, non-dimensional velocity V star is given by V upon V, non-dimensional pressure is P upon P naught minus P infinity, non-dimensional gravity G upon G, and non-dimensional del operator is L into del actually. So del has dimension L minus 1. So we substitute all the terms there, so we will get this term rho V into V star dot del star upon L bracket close V into V star equal to rho V square upon L bracket V star dot del star bracket close and V star, where this you can write here rho del dot V into V. So for this case del P, so del P would be equal to that del square upon L P naught minus P star into P naught minus P infinity into P star. So here we can write P naught minus P infinity upon L del star into P star. Rho G vector equal to rho G star G. So rho G G star. Del V square V will be equal to mu del square del star upon L to the power 2 into V star. Then rho del V upon del T would be equal to rho del V into V star upon del T star upon F would be equal to rho BF del V star upon del T. So by substituting all terms there, so we are getting these equations. Now we are multiplying this by L by rho V square. So if we are multiplying it, so finally we are ending up with these equations with some important non-dimensional numbers. Here is coming FL by V is standard number. This is P naught minus P infinity upon rho B square is Euler's number. V upon under root of GL would be Faraday number, and rho BL upon mu is Reynolds number. Now the continuity is given by this equation, that del P upon del T equal to plus del rho U upon del X plus del rho B upon del Y del rho W upon del Z equal to 0. For incompressible steady flow, we can write in this one del dot B in non-dimensional form, del star upon L minus V into V star equal to 0. So this we can write del star dot V star equal to 0. This is non-dimensional continuity. Now Stroll number here is given by FL upon V. Euler number is given P naught minus P infinity upon rho V square. Faraday number FR square is V square upon GL. Reynolds number is rho BL upon mu. So hence the non-dimensional actually Navier-Stokes equation will be ST del V star upon del T star plus V star dot del star bracket close into B star equal to minus EU del star P star plus 1 upon FR square G star plus 1 upon RE del star square V star. What are the conclusions from here? First thing, non-dimensionalized continuity equations contains no addition parameters, hence must be satisfied because all terms are of same order of magnitude. So in continuity, each and every term must be solved because all have of the same magnitudes. Second, the order of magnitude of non-dimensional variable is unity if they are non-dimensionalized using length, speed, frequency, etc. that are characteristics of flow field. T star is 1, X star is 1, V star is 1. So if we'll say multiply here that V star dot del star into V star, del star into P star are also the order of unity 1 only. The importance of each term depends on order of the magnitude. For example, ST and EU are order of 1, but Reynolds number and Faraday numbers are very large. So we may ignore gravitational and viscous terms in Navier-Stokes equations. Since there are 4-dimensional parameters, so dynamic similarity between model and prototype requires all 4 of these to be same for model type. The Stroll number ST FL upon V of model would be equal to FL upon V of the prototype. Euler number is given that P naught minus P infinity upon rho V square of model should be equal to P naught minus P infinity upon rho V square of prototype. Faraday number model V upon under root of rho GL of model should be equal to V upon GL under root of prototype. Reynolds number rho BL upon mu model should be equal to rho BL upon mu of prototype. For steady flow, F is 0, Stroll number is 0. So if F is very large such that is t less than 1, flow is called quasi-steady. This means that at any instant of time, flow is slow periodic cycles which can solve the problems if flow were air, steady and unsteady both. Effect of gravity is only important in flow with free surfaces. Effect waves, ship motions, spillways from hydraulic dams, flow of rivers. For many engineering problems there is no free surface. Correct. Pipe flow, fully submerged flow around a submarine, torpedo, automobile, motions, flights of aeroplane, birds, insects, etc. In such case, only effect of gravity on the flow dynamics is a hydrostatic pressures, distribution in vertical directions superposed on pressure field due to fluid flow. For flows without free surface effect, gravity does not affect the dynamics of the flow. Its only effect is to superpose a hydrostatic pressures on the dynamic pressure field. So this minus del P dash can be given here. Minus del P plus rho G is the modified pressures, and Navier-Stokes equation can be solved without gravity and can be substituted at the end. Now creeping flow, the Stokes flow or roll Reynolds number flow is Reynolds number less than 1 is given by this. Rho BL are very small and mu is very large for creeping flow, just like syrup, honey from a spoon. Flow in microorganism, so organism can flow as swim in air and water respectively. Creeping flow also occurs in flow of lubricating oils in very small gaps and channels of lubricating bearings. In this case, speed may not be small, but the gap size is very small, on the order of tens of microns, and viscosity is relatively large. Mu oil is 1 Newton second per meter square at room temperatures. So this is all about the non-dimensionalized equations of motions. Thank you.